today I want to walk you through what actually happens behind the scene when you play a game on xray.games. So not just the game itself, but we're going to see the contracts, the circuits, zero knowledge proof, the whole pipeline basically. So the question this architecture answers is how do you prove gameplay, verify results, build a trustless environment for players, because we can't run the whole physics engine of the game inside the smart contract. Actually, for small games it's possible, like for example the Chain Snooker does it, but the physics verification is very tractable. We only check a single momentum exchange between the balls. That works well for small games, but already for games like Chain Runner, where we need frame-by-frame velocity, friction, gravity, and obstacle collision check as well, that would not be possible, or if it is, at very high cost. But let's just jump straight into it. I'm going to give you a very quick tour of the platform first. Alright, so we are all set up now. So we have 3 games on the platform, the Chain Slicer, the Chain Snooker, and the Chain Runner. And each one has a very different type of gameplay. And that's why also it was very interesting to integrate them to the platform. And actually circuits are very game, or at least gameplay dependent. Each needs to answer a very specific problem. So for example, the Chain Slicer needs to prove a geometry-based solutions for the puzzles. The Chain Snooker, it's about physics. The Chain Runner is also about physics, but at a completely different scale, because we need frame-by-frame simulation of the run. And there's many ways actually to design your circuits in order for to solve the same problem. And the challenge is actually about to find an efficient way to do so. And I will show you in details how it was done for xray.games. So if you click on the option here, you will see that we support both Circom and Noir backends. Personally, I prefer to design the circuits using the Noir language. I think it has a better abstraction for developers. It's very similar to Rust. Circom, you need to think a bit more in terms of signals and constraints, so it's a bit less of a logical approach, but Noir has a better abstraction definitely for developers. We also support Ohloss, and actually the Chain Runner game has been added today, whitelisted on the mainnet contract by Tyler, so we'll be able to have a run on mainnet with a real wager. And then we also have leaderboards here. As you can see, you can sort also by wager. So Chain Runner, let's play it. The goal is simple. I will just show you. Let's put 10 wagers. So it will ask me, so the Ohloss signer, use your Ohloss account. So you will need to create an account on Ohloss to use it. And yes, the goal is very simple. You control a sticky blob, and the goal is to climb up and collect the stellar coins. You will see you can hang onto the wall as well if you want to power up your next jump, and the goal is to reach the target. So here my target is 12, and you have as many tries as you want during the 2 minutes session basically. So it doesn't matter how many times you fail. What matters is that you reach the target that is given to you during that time in at least one of the tries. So hopefully I will be able to, no, oh yes, I just did it. So I can end the game now, I win, and I'm gonna submit the proof. We will check into the browser after, and then I will explain what happens behind the scene here. Alright, so skill verified. That means now I can bring the inspector and the Stellar Expert page, so we can see what's happening behind the scene. So as you can see here, we call the start method on the contract, provide the player address, the commitment, and the wager. So the commitment essentially is a commit reveal scheme, and it allows you to delegate the end session call to the server. So that you just send your prover data, your witness data to the server, generates the proof, and call the contract on your behalf. But you don't have to do so. If you call the start method successfully, then it returns the seed, which is a Poseidon2 hash, and it's used to deterministically generate your level. It also provides the target that you need to beat in order to contribute your faction point for the Ohloss protocol. So let's get back to the inspector. Here you can see that the seed is forwarded to the server on the start endpoint, and the server replies with the level data and also an attestation that is signed and that is going to be verified on the blockchain. The hash also will be verified by the circuit as well. So let's check quickly on the Stellar Expert. You can see the end call here. We provided data, and then there's a cross-contract call to Ohloss, and then determining the winner and contributing the function. I can show you in the code directly. Here you can see in the end call we verify the attestation. So the verification of the attestation verify the signature from the server. We also run the Growth 16 verification on the proof. So thanks to protocol 25 xray, we now have access to primitives in order to do this on chain. And if everything is fine, then we call Ohloss and specify the winner and return the score, which is what happened here. As you can see here, we got the score, and that's when the game prints skill verified on chain. So that's it for now. We'll definitely make additional video as we integrate more games. And if you have any question, don't hesitate to let me know. See you for now.